It's a common theme throughout the modern world that everything in a computer's brain comes down to ones and zeros. You've most likely heard that this code of ones and zeros is what's referred to as binary. And while almost everybody knows that this is somehow related to what computers do, very few of us seem to understand what binary is or why computers use it. If you want to know, then this video is for you, because it's actually a very simple concept and still quite fascinating. Before we get to computers, let's talk about what binary itself is, as it existed long before computers did. Binary is nothing more than a system of counting. To understand how it works, let's look at two other systems of counting, tally marks and the glorious base 10 positional that we all know and love today. Tally marks are the simplest counting system imaginable. However many things you have, you put down that many marks, easy as pie, but not very efficient. Meanwhile, base 10 positional, which is what we use today, uses a different symbol to represent different amounts of things. With the numbers 0 through 9, we can recognize that each symbol indicates a different amount of things. If we need to represent something higher than 9, we add a digit to the left, roll its first digit back to 0, and start over. This system, we add a new digit every 10 things. Each digit represents an increasing power of 10. This is the number of ones we have, the number of tens, the number of hundreds, the number of thousands, and so on. Now this is probably something. Now binary works the exact same way as base 10 positional, but instead of each digit going from 0 to 9, it goes from 0 to 1. Counting upwards in binary sounds like this: 0, 1, 10, 11, 100, 101, 110, 111, and 1000. Because each digit of binary has only 2 values and not 10, each additional digit represents an increasing power of 2 rather than an increasing power of 10. So this is the number of ones we have, the number of 2s, 4s, 8s, 16s, 32s, 64s, 128s, and so on. Not nearly as efficient as base 10, but exponentially more efficient than tally marks. Literally. So now that we know how binary works, let's talk about computers. Why did the first computer creators, as wise and intelligent as they are, waste their time with such an ineffective system of counting? Well, it's because of a physical limitation on how computers work. Everything a computer does comes down to what's known as microtransistors. Simple, tiny, eensy-beensy little switches that can either be on or off and can be flipped on or off with a very weak electrical charge. The first goal was to get computers to count, and to get them to count by using these switch binary, where each switch represents a digit of binary. 8 transistors using the tally system could represent a number as large as 8 by turning all of them on. With binary, we can represent a number as high as 255. An on switch means a 1, and an off switch means a 0. Now is a good time to mention that a single transistor is what's known as a bit, which stands for binary digit. A byte is 8 of these bits in a row, which means any number between 0 and 255.